Hello, welcome back everyone. And this week we want to dive into sort of the next topic on our syllabus, which is living with nature. And so really what we're going to be thinking about here are some of the larger hazards on Earth. So we've talked a little bit about toxicants and how those move and how we think about toxicology and how we think about toxicokinetics and things. And now we want to start thinking about how we think about other hazards that are present. So things like infectious disease, poisons, natural disasters, and naturally occurring radiation are going to be the topics that we're going to be talking about this week. And so we're going to start with infectious disease. And I want everybody to just pause for a second and think back to what we talked about on the first day, which is that we really want to take sort of this sort of environmentally centered view, not the human-centered view, really, because these different organisms, these different infectious diseases are sort of working as part of a much larger network or a much larger ecosystem. And so I pulled this from one of my biology lectures because I think it's really important to think about all of the really complex interactions that are happening inside of an ecosystem. And so all organisms have to transfer energy and matter to create energy, to grow, to develop, to reproduce, right? And part of this transfer of energy and matter in these ecosystems leads to populations that are dynamic. Some years populations are larger, some years conditions are more favorable, which leads to populations increasing or decreasing. And because all of these different populations, and again, this is sort of using the Arctic tundra, so we have the grasses, and then we have the organisms that feed on the grasses, like the snow goose, and then we have the reindeer that feed on the grasses, and then we have the predators that feed on the reindeer and the snow geese, right? All of these populations are dynamic, and if the grasses don't grow, then the snow geese can't reproduce as well, which leads to less food for the Arctic fox, etc. And so certain years or times of year, these populations change in size, they change in their spread, they change in their density. So these populations are constantly changing, which leads to a diverse set of interactions between these different populations. So predation rates are going to change, herbivory is going to change, symbiotic relationships, symbiosis, competition between different organisms is going to change because of these sort of complex features of an ecosystem. And so I want you to just kind of tuck that in the back of your mind or use that as a lens to view this discussion. Because as we're going to see, or as we're going to talk about, yes, we have these organisms. We're going to think about how we control these organisms, how we think about these different hazards, but we always have to put this in a much larger context of the entire ecosystem. And so I want you to just frame this conversation in that way. And so with these species interactions, we can think about sort of boil this down to a few different types. So competition, right, where two species are competing, and so that competition leads to harm to both species. They're not helping each other out. They're actively working against one another, competing over a similar resource. Exploitation, these are going to be sort of a general category for things like predation, parasitism, herbivory. This is where one species is going to benefit, so the predator or the herbivore is going to benefit from this interaction, and the other species, the prey or the foliage, is going to be hurt, right? Because they are being eaten and killed. Parasitism is another example of this, where the parasite is feeding off the host. The parasite benefits, but the host does not. And then mutualism is where both species benefit from one another. Now, these are sort of the larger scope of all of the interactions that we can talk about. But when we're thinking about infectious disease, we're really focusing specifically on the exploitation. So we have lots of different organisms living on and around our body. And some of these are good organisms. We need bacteria and things in our gut to help with digestion. We need microorganisms on our skin to help protect us, right? So there are many sort of mutualistic organisms and things that are living on and in our bodies all the time. However, infectious disease is sort of a host-centered concept where these are going to be associations that harm or bother us, right? So this is sort of moving us into that exploitation. One species, the infectious disease, is going to benefit, and we are going and we are not, right? So one species is going to get the benefit and the other is not, and that is going to lead to a disease state. And now some of these diseases are very serious and can lead to death. Other diseases are just going to lead to an itchy rash that will either go away on its own or we can treat, right? But these are negative associations between the host and the infectious agent. Some of these are going to come from nature. Some of these are just going to be in the soil or in the air. Other ones are going to come through zoonosis, which is an infectious disease that is transmissible to humans from other animals. And so we're going to talk, so again, just focusing ourselves on the specific types of interactions that we're going to think of as infectious. There are also many different types of pathogens that can lead to infectious disease. And some of these are going to be worms. Some of these are going to be protozoa, right? Little single-celled eukaryotic organisms. Some of these are going to be bacteria. So you've heard about a staph infection or strep throat or salmonella, or we're reading now about cholera. So these are going to be bacteria. We're also very familiar right now with viruses, with the COVID-19 pandemic going on right now. Viruses have become sort of a major pathogen that we are very familiar with. And prions are a unique set of proteins that can sort of turn on a body and attack particular body parts. But any one of these could be considered a pathogen. And our body doesn't just sit back and wait passively for these pathogens to attack us. We have an immune system which is able to distinguish our own body tissue from these foreign invaders, whether it be the worms or the protists or the bacteria or the virus. And so we have systems in place that can fend off these different invaders. And so we have different active immunities, right, that our bodies can use to respond to this. We can also use technology for sort of passive immunity, right? We can do things like vaccinations. We can either present small pieces of the antigen, which would give us active immunity, or we can present antibodies that will fight off, which is a passive immunity. We're also hearing a lot right now about herd immunity, which is sort of a practical protection where if we have enough members of a group immunized, this is going to make it more difficult for these different pathogens to jump from one individual to the next. And so these are going to be the topics, sort of these different infectious diseases, and then how our bodies fight against that is what we're going to be starting our conversation with today. And so now I have a series of 3 videos that's going to take you through and talk a little bit about some of these different infectious agents, and then our immune system and how that works, and then thinking a little bit more deeply about vaccines and how vaccines and antibodies and antibiotics can work to help us fight off these different invaders. So please flip over or go back to D2L and watch these 3 videos, and then I'll be back with you in just a minute.
We're going to take a look at infectious diseases, what they are, some terms used to describe. We're going to take a look at infectious diseases, what they are, some terms used to describe them, and take a look at a few different
An overview of all the major body systems is nice, but something remarkable happens when you explore one body system at a time in a bit more depth. And, in our opinion, one of the most fascinating systems of all is the immune system. Why? Antibiotics, antivirals, vaccines. Have you ever wondered what they do or how they work? Antibiotics, antivirals, vaccines. Have you ever wondered what they
We're going to take a look at infectious diseases, what they are, some terms used to describe them, and take a look at a few different types of infectious diseases. First of all, what is an infectious disease? An infectious disease is a disease caused by an infectious agent like viruses, bacteria, parasites, or fungi. Infectious diseases are a global problem, and in the past, used to be the leading cause of death. There were large epidemics of smallpox, TB, syphilis, cholera, and plague that caused millions of deaths around the world. The 1918 influenza pandemic alone was responsible for the death of around 40 million people globally. Thankfully, advances in nutrition, antibiotics, immunization, food safety, housing and sanitation has led to a massive reduction in infectious diseases. However, even now, they're a problem. In 2012, infectious diseases were responsible for 3 of the top 10 causes of death in the world. These 3 were lower respiratory tract infections, HIV/AIDS, and diarrheal diseases. In addition to this, malaria and tuberculosis continue to affect millions of people. New diseases like Ebola and MERS-CoV have sprung up, causing deadly outbreaks and killing thousands of people. Let's have a look at what happens when a person gets infected and talk about some terms that are used to describe infectious diseases. When an organism enters the body, some people fight it off with their immune system, while others can go on to develop disease. People are likely to develop disease if they have weakened immune systems. This could be due to drugs, age, or other disease. They're also more likely to develop the disease if they're not immune to it. For example, if they haven't had the disease before or if they haven't been vaccinated. The time from when someone gets infected to when symptoms start is called the incubation period. The clinical stage of the disease is marked by the onset of symptoms. There can be considerable variation in the clinical stage, ranging from very mild symptoms to very severe symptoms. The disease lasts until the infection has resolved or the person dies. Now, for some important terms that you'll hear when describing infectious diseases. The infectious period is the time during which the infected person can spread the disease and infect others. Sometimes people may not have any symptoms, but still be able to infect others. These people are called carriers. Case fatality is a measure of the severity of a disease. It is the proportion of people that die from being infected. For example, if 6 out of 10 people with the disease die from it, the case fatality is 60%. The basic reproductive rate is a term that describes how infectious a disease is. It is the average number of secondary cases that occurs as a result of one infected individual. For example, measles can have a basic reproductive rate of up to 15. This means that one case of measles can cause up to 15 other cases of measles. Another way to measure infectiousness and the spread of disease is the secondary attack rate. This is the proportion of people who are exposed to the disease that develop an infection. For seasonal influenza, it's about 10%, meaning 1 out of every 10 susceptible people exposed to an influenza case will develop the infection. Now, let's have a look at some important categories of infectious diseases. Zoonotic diseases are diseases of animals which, when transmitted to humans, can cause disease. It is estimated that over 60% of human infectious diseases are zoonotic. Examples of zoonotic diseases include diseases like leptospirosis, toxoplasmosis, campylobacter, and rabies. An emerging infectious disease is a disease that has appeared in the population for the first time, or one that may have existed previously but is rapidly increasing in incidence or geographical range. Examples of emerging infectious diseases include MERS-CoV, Ebola, Hendra, and new influenza strains. Neglected tropical diseases are a group of tropical diseases that affect the poorest countries of the world. Traditionally, they have not received much global attention but continue to cause illness in the most vulnerable groups of people in the world. They include diseases like leishmaniasis, trachoma, sleeping sickness, and schistosomiasis. Vector-borne diseases are diseases that are transmitted from an infected animal or human to another person through the bite of a vector. The most common vector is the mosquito. Others include ticks, flies, fleas, or snails. Examples of vector-borne diseases are malaria, dengue, sleeping sickness, and schistosomiasis. Vector-borne diseases are responsible for over 17% of all infectious diseases and cause more than 1 million deaths each year. So that's a quick introduction to infectious diseases, what they are, some terms to describe them, and a few different types.
An overview of all the major body systems is nice, but something remarkable happens when you explore one body system at a time in a bit more depth. And, in our opinion, one of the most fascinating systems of all is the immune system. Why? Because it features cells in your body that work day and night together to protect you from a constant threat of pathogens trying to bring mayhem. And most of the time, you don't even know it. Most of the time. By pathogen, I could mean a lot of things. A lineup, viruses, bacteria, fungi, protists, parasitic worms. We could go on. Your body has external protection against these things, like your skin. We call that a first line of defense because it's the first line against letting these pathogens inside your body. Mucous membranes, too, like the lining of your nose, will keep pathogens from getting inside. This first line of defense is non-specific because it's not selective about what it blocks from getting into your body. But this is all not foolproof, and sometimes they do get in. And when they do, your immune system has all kinds of ways to deal. After all, this is not its first rodeo. So